exploring the intersection of resilient technology, organizations, and people. REdeploy.
In the years around 1580, in the city of Florence, Italy, in the home of Giovanni de Bardi, Count of Vernio, a group of people came together to solve a common problem. They called themselves the Florentine Camerata. And their mission was to reform modern music, what Vincenzo Galilei, father of Galileo, called the corrupt and incomprehensible music of the day, according to Wikipedia at one point in time. It was polyphony, and it sounded like this. Now, incomprehensible I'll give him, but it's not corrupt. It's maximizing for holiness and beauty and beautiful feelingness. And it's got like 4 to 6 melodies, all intertwined, all equally important, and it's very, very nice. But the Camerata asked the revolutionary question, what if we could understand the words? Specifically, they wanted a kind of music that optimized words and music together to express a feeling and a story. I find the story of the Camerata super fascinating, in part because it reminds me a little bit of a modern Agile team. They came together and they're not just musicians. They're singers and composers, but also philosophers and scientists and astrologers and merchants and clergymen, all different kinds of people, everyone who is interested in thinking and talking about this topic came together regularly in the homes of Giovanni de Bardi and Jacopo Corsi. So they had sponsorship. They've got diverse concerns and sponsorships. They had a common purpose and even some common methods. So their strategy was to revive how the ancient Greeks combined words and music. Now this is a little iffy because they didn't actually know, right? They didn't have recordings of the ancient Greeks, but they did like study their works, and some people figure they said that they were reviving the work of the ancient Greeks because it lent legitimacy to what they were doing, because back then they thought that history moved in a circle instead of a progression. So this is kind of like when we cite computer science papers from the 1970s. The Camerata talked a lot. The son of Giovanni de Bardi remarked, "Oh my gosh, they get together and all they do is talk. Nobody gambles or drinks." But Caccini said that he learned more from their learned discussions than 30 years of descant. So descant, I had to look that one up. That means lecturing, what you're getting now. Fortunately, there's a lot of learned discussions going on at this conference. They didn't just talk, they also experimented. They wrote music and played music as a workshop. And they didn't always get along, kind of like our team. So Bardi and Corsi, the two chief sponsors, Bardi wanted to do more talking and Corsi wanted to do more playing music, but this balances out. And then Caccini and Perry, Caccini was like, it's about the music with some words, and Perry was like, it's about the words with some music. But these also balance, you know. They did code review. I find it interesting that the censors were appointed to criticize the work. It wasn't just that asshole who doesn't like you and takes it out on your code. In the end, the Camerata totally succeeded. They made history. They invented the stile representativo, also known as monody, the shocking idea that perhaps we could listen to a single melody with musical accompaniment. Here's one of the first operas around 1600 that we still have today. This is Monteverdi. So that's still incomprehensible to me, but I don't speak Italian. And I hear that even if you do speak Italian, that doesn't help, because it's ancient Italian, so that would be like reading Chaucer or something. But still, back in the day, it was communicative to people, and it did convey a feeling and a story like the Camerata hoped. And opera was a big hit, still is. But one of the fascinating things that really caught my attention about the Camerata is what the people who were in that group did afterward. So these are some of their publications from Wikipedia, and these are fewer than half of the Camerata members who have Wikipedia articles today. But their publications, yes, include operas, but also philosophy, scientific treatises, poetry. These people came together to solve a problem, and they became great themselves. This also happens in other fields. All the quotes in this presentation, unless otherwise attributed, are from this paper, which I found in the Journal of the History of Ideas about the Camerata and collective problem solving. And Dr. Katz, who's a musicologist, she compares the work of the Camerata, the way they worked, with the way scientists work, because we like to give Nobel Prizes to individuals or sometimes pairs, but that's BS. Who worked in their lab? Who did they correspond with? When the world is ready for an idea, it doesn't come to just one person. Lots of people contribute. So the invisible colleges are like these meetups or just people who write to each other. Camerata epitomizes that. Some examples of properties of invisible colleges and the Camerata. Tacit understandings about methods of research, so what is an appropriate action. Priority problems, that means fighting over who was first. We'll get to that later. And also the shorthand communication, so they share a common ground and a common understanding that lets them communicate really efficiently. In science, one of my favorite examples, there's a great book about Joseph Priestley. He's credited with the discovery of oxygen, but I think more interestingly, he was the first one to put a mouse in a jar and it dies, and he counts how long it takes. And then he puts a plant in a jar and it dies. But then he discovers that if he puts a mouse and a plant in a jar, they don't die as fast. So thank you to the mice and plants who were sacrificed so that we could discover the oxygen-carbon dioxide cycle. But people didn't get excited about that until like the 1920s. This was Franklin and Priestley. This is before the American Revolution, just right around the time of the American Revolution. Because they were involved in religion, politics, biology, and chemistry. Priestley influenced all of these fields. Ecology didn't come around until the 1920s, so that was a little slower. But one of the ways he did this was within this Camerata, the Club of Honest Whigs at the London Coffee House. They met fortnightly to dine and drink and talk about science and politics and things. And the coffee part of that is important because it turns out that one reason the Enlightenment was a big advance in human science is that this was just after they started importing coffee all over the place, and people were drinking coffee with breakfast instead of beer, and they got smarter. So every field was new again, and whole new fields emerged. It's pretty cool. There's more on these people. That's a really interesting story of a Camerata. Of course, this also happens in art. You've got the famous salons. This is one of the salons in Montmartre in Paris. It's called the Agile Bunny, which is extra appropriate. And these are places where not just painters, but also critics and dealers and all the stakeholders in the art industry got together to discuss and solve problems. Some of the common puzzles that they solved in art were like the different styles. So for instance, with Impressionism, it was how do I paint not what is, but what I see? Van Gogh, for instance, where did he go? And then they all lived together in the same houses and interchanged ideas. Here's Van Gogh in the Netherlands before he came to Paris, and here's Van Gogh after he gets to Paris. Lot more color. His brother Theo is like, wow, you've managed to create a circle of artists and friends that he learned from and who learned from him. And some of the paintings of Gauguin and Toulouse-Lautrec show up in 20 years later in the salon of Gertrude Stein, and she's got philosophers and mathematicians, and then Picasso is one of them, and he goes on to make money, and so then he's running his own salon with more photographers and philosophers and all different kinds of people. One of the people who visited him and was influenced was Alexandra Extra. She takes her new ideas back to Kiev, and these are a couple people she went to high school with, and Alexander Bogomazov painted this painting, which is on my bedroom wall today. So these ideas, they build on each other when we share them, and we grow faster for the sharing of ideas than we possibly could alone. This happens in software. A couple of my favorite examples are ThoughtWorks London, around this time, and this is people who work for ThoughtWorks but at different clients, but they came together to solve the common problem of how do we deliver software faster, easier, safer, more frequently, all of these things. And so we get CI/CD out of that. Jez wrote a bunch of books on DevOps, but then some of the other people involved, Dan North invented behavior-driven design, Nat Price has some unit testing stuff, Sam is the prophet of microservices. They all went on to do different interesting things. This also happened with the Spring team. They came together to solve the problem of how do we do Java EE without stabbing our eyes out. And they succeeded at that, and now Rod is my CEO and Christian's my VP, and we're always running into people at conferences that I'm like, oh, who's this Rob Harrop dude? And they're like, oh, we know him. The evidence is that you want to think you can get a bunch of great developers and put them together and get a great team. It's the other way around. Great teams make great people. So why is that? How does that work? And that brings me to a model that I really like. And that starts with Gregory Bateson. Gregory Bateson was a cyberneticist or cybernetician back in the day. Cybernetics eventually evolved into systems thinking. But he was Macy's Cybernetics Conferences. That's one of his camaradas. They met like 10 times in 8 years or something. And he was an anthropologist in there. But it's a cross-field. Cybernetics is very cross-field and integrational discipline. His father, incidentally, was William Bateson, who was a biologist who coined the word genetics. And of course, he didn't do that by himself. He's building on the work of Gregor Mendel, and he had a bunch of people in his lab helping him, and they're all women, his wife and a bunch of other women, because the men didn't think it was real biology. Yeah, genetics is real biology now. So anyway, then he has Gregory, and Gregory contributes a lot to systems thinking, and also he contributes his daughter, Nora. And Nora takes this a little farther. She says, systems are important, but when we think about systems, it's too easy to think about machines, to think about stocks and flows and mechanical movements of things, and think about like fixed, hard machines. And that's not, those aren't the kind of systems we live in and work in. So she said, we need another word. And she coined the term symmathesy, from the Latin sim, together, and mathesy, learning. So symmathesy is a learning system composed of learning parts. And it's the mutual learning of the parts that makes it important, or that makes it different, and that makes it really extra powerful. Back in the 60s, dozens of grad students spent years of their lives counting blades of grass, because if we could just put enough numbers into the model of the ecosystem, then we could predict outcomes. Nope. Nope. Because every blade of grass is different than the one before it, because we're learning. So our team is made up of people and our environment, our desks and stuff, that's represented by the leaf here, but also the relationships between us. And Agile starts to recognize that, but also all of our past interactions have created who we are as people and as a team. Whoops, would you please play again? So a system is not the sum of its parts. We know that. That would be an aggregate. It's also a product of their interactions. But Nora takes this farther, and a symmathesy recognizes that the parts are a product of the past interactions. This is really powerful. This is not a zero-sum game. So our team is a symmathesy. The Camerata was a symmathesy. But in software teams, I think it goes even further, because we are more of a symmathesy than the Camerata was, because our software is on our team too. So if I define my team as everyone necessary for me to succeed, regardless of their place in the org chart, and I define success as a developer as impacting the lives of my customers in a positive way by running useful software in production, then that useful software in production is part of my team. And so are all the tools that I use to get it into production and to change it and to find out what it's doing and to listen to it. And this starts to help me understand why programming is so hard now. It also tells me why we need to show up to work with our whole selves, because if we're going to be part of a living system, we need to be alive within it. It didn't always seem this complicated, because when I started as a programmer, it was just me and the program that I worked on, and I did the changes that I was asked to do with only a little pushback. And if I needed to use some data, to store some data, I would say, how do I use the database? These days, I say, which database shall we use? Or databases, and caches, and how shall we shard them? So as I grow as a developer, I get more scope. I understand more of the system, and I'm able to influence more of the systems. My relationships with other people on the team are stronger. And then if you expand that even farther and you get into senior developer or architect or high-level individual contributor, or whatever you want to call it, then I'm starting to have an influence over more of the system than just my team, and I understand more of it. Maybe I work on tooling that impacts lots of systems. And if you flip this inside out, then you get management, which is focused on the social side of these socio-technical systems. Charity Majors has a great blog post about the benefits of switching between individual contributor and management every 3 to 5 years, because if you have influence over both sides of these systems, that's really powerful. The senior developer, which I'd rather call like, I want to say like a wide developer. I want to increase in breadth rather than age. The senior developer has really strong bonding social capital with the team, and also relationships outside the team. So this is bridging social capital, which is outside the team. The team is like getting stronger inside, but you also need influence and information from other teams, from other parts of the company, and from the world outside. So we are building bridging social capital with each other at this conference. When we talk to each other, we get more perspective. That's helpful. I also think that when you look at it this way, as a senior developer having an understanding of the broader system, why would you think you could hire that? Nobody knows your system. The best you can hope for is to hire someone who's achieved that before and maybe can get there faster. But if you want somebody to get a breadth of the system faster, that is in conflict with them being productive quickly. Because if I want to be productive quickly when I started a company, I'm going to have to zoom in and get to know some piece quickly enough to get to move on it. So personally, I don't hit the ground running, and I am incredibly slow to get started in a new job, because every time I hit something I don't understand, I'm like, stop the line. I got to figure this out. Now, once I get there, which takes about a year, I can be pretty effective, but it's totally different from being productive quickly. So if we zoom back out, I want to finish this diagram, because you may recall from John's presentation yesterday that there's something missing, and that is the line of representation. Because this team cannot just look down and see what their software is doing. Until Tron is a thing, they cannot fight problems directly and get down there and tell their software what to do person to person. No. We have to work through the screens, command lines, mouse clicks that we provide for ourselves with our tools. So SSH at the crudest level, our source control and our code editors that let us read the code to predict what it's going to do and then change the code to change what it's going to do, and our log aggregators are part of the line of representation. And of course, our automated tests are down there, and we can change those. But we are limited in what we can see. I love the line of representation. I was so excited when I read this in the Stella report, because it lets me explain Atomist in a few seconds. Atomist is about giving developers tools to move more work below the line without moving the important decisions below the line, because we keep a line of communication to the developers in chat. Oh, do you want to deploy this? Here's a button. So that's fun. But when we have this model of the system, this symmathesy, what can we do with that? In systems like ecology and economics, they measure the magnitude of a system by counting the flows, all the movements of, pick your currency. So this is GDP. Every time money moves around, it counts toward GDP. In ecology, this might be carbon exchange or energy moving from organism to organism. And the system gets bigger as those flows get more active or involve more people or animals, whatever. If we look at our team as a symmathesy, then we can ask, what would happen if I took this strategy of maximizing the flow of learning? So I might do more to teach my tools, to move more of my work down below the line, anything that I want to be consistent. Because computers are good at consistent, while resilience is in the humans who are quite capable of doing everything differently every single time based on the situation. And I would give myself more tools that I can learn from. So like Humio or Splunk for logging, and then I learn the query language, and I can actively learn more from my system using that tool. Or Honeycomb for spontaneous observability queries for really digging into what's happening. And then you start putting observability or learning tools into your software itself. This can be log messages or event emissions, but it can also be like admin screens. We think a lot about user experience, but what about operator experience? I've worked on a software system that the admin screens were so good that we as humans were able to hold that thing together for years longer than it deserved because it was a mess. Oh, the cache, oh my gosh. The software was a mess, but the admin screens were so good that we could figure out what was going on. And we just had 2 full-time developers keeping it up. So if we think about maximizing mutual learning, of course that also includes learning from each other, which is trickier than we think it is. One reason is those pesky mental models. So because we can't work with the software directly, we're doing our cognitive work based on the mental model that we have of the system below the line, and also of each other and people and stuff. And Woods' law says that for any sufficiently complex system, it is guaranteed that your mental model is incomplete and out of date. And everyone's mental model is incomplete and out of date in different ways. And that's actually good, the incomplete in different ways part. Because you need some overlapping, you need some commonality, you need that common ground so that you can have that shared communication in your Camerata. But you also don't want everybody to have identical mental models because that would be kind of useless. The thing about our software systems is the limitation for making constructive forward change. The limitation for moving the software forward without screwing it up and taking 2 steps back is it's not how much we can do, it's how much we can know. And Cesar Hidalgo, who's a statistical physicist, talks in How Information Grows about there is a finite limitation to what one person can know. Our knowledge and know-how that lets us work in the system is limited. He calls that limit a person byte. It doesn't matter what quantity is a person byte. What matters is that it's finite and that because we're successful, our systems are more complex than any single person can hold. And that's why we need to form networks of teams with overlapping but not identical mental models. We need knowledge of different parts of the system. So we need someone who understands UX, we need someone who understands security, and someone who understands accessibility, and someone who really understands Kubernetes and like the internals of the JVM, and also, I mean, that's just the easy part that I can name because I can't name the really important stuff, which is how each individual system works and is different everywhere. But those overlapping mental models are crucial. And we're still limited in how much a team can do because adding a person has a cost. You need that overlap and you need to create that overlap and maintain that overlap, that common ground, and that's your cost of coordination or your coherence penalty of adding another person. So there's a trade-off. And because our limitation is often how much we can know, I think mob programming is a really important technique in software development. Because mob programming is like you get the whole team, so maybe 5 people, and you're all looking at the same screen, and there's one person with a keyboard, and you take turns every 5 or 10 minutes, whatever, you swap off with the keyboard. But the person at the keyboard does not make any decisions. Every decision is vocalized and only entered by the person at the keyboard. And this way you pool all the knowledge and bring your mental models into alignment. I think that's a really important technique. Right, one of the reasons it's way harder than you think to get these mental models in alignment is another law. This one came from Valentino Breitenberg, who's a philosopher in the 60s. The law of downhill invention, uphill analysis. And this says that it is easier, counterintuitively, it is easier to build up a complex system from scratch, constructing your mental model at the same time, than to come to a complete complex system or an operating complex system and figure out how it works. That's actually harder. This explains why there are 1,000 JavaScript frameworks. Because it is seriously easier mentally to build your own JavaScript framework that does exactly what you need it to do, and then kludge on and on and on to make it do what you do, and you're building up your mental model, and it makes complete sense to you, and of course everybody else thinks it's terrible. But that's easier than learning React. Than really understanding a framework that someone else wrote, no matter how many people spent hours and hours of their lives creating documentation and answering questions on Stack Overflow. So, not invented here is a thing, and while it is more work, and it feels really productive to build it yourself because you're doing a lot more programming, it is mentally lazy. This also explains the phenomenon, or a good portion of it, of the 10x developer. So in this example, the purple developer has a great mental model of this system, probably because he wrote it. And purple is busily working along and changing stuff in the system, but maybe he wants to move on to something else, whatever. They assign a couple more people. Blue and green come in, probably part-time. And they're supposed to just pick up and work on the system too. And they're trying to form a mental model of how it works. But in the meantime, purple is changing it faster than they can get a grasp on it. I've been in this position multiple times, and I felt incredibly stupid. And purple developer probably thought I was pretty darn stupid. But purple developer is the problem here, because it is totally possible to change a system that you deeply understand so rapidly that no one is a sufficiently smart developer to get a grasp of what's going on. So the solution here is purple is that expert that Vicky talked about, that it's really, really hard to get that expert knowledge, that mental model, out of purple's head. Now, I learned yesterday from Ty a technique that he uses for this called field interviewing, and I hope next year he will do a talk on it here. That's really interesting, because so far the only thing I've ever found that works is pair programming, or even better, mob programming. So if purple only changes this system through the hands of blue or green, then through that shared work, their mental models will sync, and that knowledge will pass between them. Because one thing about a complex system, like learning and changing are the same activity. Like you have to change it in order to learn from it. And when you learn from it, you're changing it because it's a symmathesy. But does purple have an incentive to do that? Usually not. Purple is sitting here looking super smart. And this gets back to those priority problems and the conflict between individual versus group interests. So in science, you've got the problem of, do I keep this to myself until I can publish it and get credit for it and win the Nobel Prize? Or do I share it so that this idea can grow? In the Camerata, you had Caccini and one of the other members that starts with R. They were arguing over who invented the stile representativo. Well, from my perspective, it doesn't matter. I can understand the words of songs today, and I can think I don't care who did it. Ideas are like that. Ideas aren't conserved like energy. When you release them, they can grow and people bring them back. But if what we're optimizing for is our annual individual performance review, that doesn't work. So I don't want to work on a team where people optimize for productivity. I want them to optimize for generativity. Now, I'm using this word as I found it in the Journal of Occupational and Organizational Psychology, but they didn't define it. I had to define it myself. That was an article about executive teams, which have a lot in common with software. Executives boss people around, and we boss the computers around. But generativity is the difference between the team's outcomes with me versus without me, as opposed to how many JIRA tickets did I close. I want to be evaluated on who did I help. What error messages did I add or improve in the system that saved a dozen people from this day of headache that I just experienced? Generativity, and generativity says that the output of our work is not just our side effects on the world, it's also the next version of ourselves and the next version of our team. So it's like Aaron said yesterday at lunch, Netflix cares about long-term decision making. It's not just about what's going to get something done today, it's about who are we going to be and what are we going to be able to do in the future. So that's a lot better. And it's surprising that if you focus on that, if you optimize for the team and the future of the team, you will become that great developer. Because if you're having trouble hiring sufficiently smart developers, that's because they don't grow on trees or anything else. Great developers aren't born. They aren't self-taught, that's for sure. No one is going to magically know your system as soon as they're hired. Great developers are symmathesized. So that's cute. But also there's one more thing that I got out of this Camerata paper that like really, really surprised me. And it led me to an idea that's audacious, and I want to see what y'all think of it. It starts with the surrounding culture. The Camerata did not invent opera in isolation. This is the late Renaissance in Florence, which is the center of the Renaissance. This is like the cyclone of developing Western culture. And the Camerata were like midwives to a century pregnant with ideas from which opera emerged. It wasn't just them. One of the things that enabled this was the idea of systematic testing and measurement. So the scientific method is just beginning to be a thing in the Renaissance. Vincenzo Galilei is the first recorded person to systematically measure how long a string needs to be to make a C, and how long a string needs to be to make a C the next octave up, and to find those ratios, those consistent ratios, and also of the tension in the strings, and then the chords. And this may have been useful to the Camerata. In the Enlightenment, Joseph Priestley had all kinds of new equipment because of the Industrial Revolution. So he had new ways of working. Today, we have systems thinking. And we have computers that let us do math we couldn't do before. So we can move beyond solvable equations. We can move beyond closed deterministic systems, thinking Newton's laws of motion, that are always at equilibrium and not exchanging energy with their environment. We can talk about open systems with fuzzy boundaries that are far from thermodynamic equilibrium, also known as every system that we actually experience as humans. And we can think rigorously about these now because we have new ways of thinking. They had the printing press that probably helped them with their research into ancient Greek. We have the internet, of course. But it's not enough to have knowledge available because one person can only hold so much. We have to interact and we have to have conversations with each other. So the other thing that made the Camerata's work possible was that they had these mixed interest groups. They had specialists in science and in philosophy and in music, all interchanging ideas and relating them to each other. And one reason that was possible and wasn't before is that, and this was the thing that really surprised me, before the Renaissance, art with a capital A was not a thing. And I'm like, whoa, there was a time before art was a thing? Yes, yes. Painting, in the Middle Ages, painting and playing music and sculpting and poetry, these were crafts. And they had guilds right alongside the bricklayers guild and the person who puts the shoes on the horses, whoever that's called, and the blacksmiths. And if you wanted to be a painter, you joined the painting guild. And you got into the painting guild because your dad was in the painting guild. It wasn't about talent. And if you hired a painter, you could be quite certain that they could produce a reasonably representative image of whatever it was you asked them to paint. But then the guild started losing power, and people started recognizing that there's some common thread between poetry and painting and sculpting, and they couldn't name it, but they understood that there was some essence that not everybody had. I would call that creativity these days. They probably didn't have that word. And the guilds lose power, and so individual artists start to excel, and then there's a merchant class that can hire the prestigious individual artists. And these cultures started coming together. So instead of painters hanging out with painters, you get academies where they study lots of things and interact with each other. And you get these cultured circles like the Camerata. So the negative is, if you hire a painter, they might not be any good. You've got to actually do your research. Not everybody has a computer science degree anymore. But the positive is, as we come into these circles together, we go from painters hanging out with painters to everybody talking to each other, like in the Camerata, we break down barriers and we break down the existing order a bit and we start to build something new. And this new style emphasizes expressive qualities. It is about impact on the customer. It is not about, did I follow design patterns out of a book? It's not about, do I have 100% test coverage? It's about, does this express something that makes the customer's life different? Software is not a craft. And I am not a crafts person. I'm also not saying that software is art, though. I don't think software is an art. Art has an impact on people. It has an impact on my inner world when I see a painting or I listen to a music, and I might be changed inside. Software is more powerful than that. It changes our outside world. When I pick up a box and I move my finger in a certain way, a car pulls up and takes me where I want to go. That did not happen 10 years ago. Software was crucially involved in that happening. Software as a material is unlike anything we've had to work with before as a human race. It is more flexible than plastic. It is more malleable than metal. We can almost design right into it. Almost. And so we can learn from it so much faster. And we have computers that can do models, and we are smarter than we were. Every field is new again, and whole new fields are emerging. So no, I don't think software is an art. I think software is the next thing after art. And this is the next thing after the Renaissance. The closest I can come to putting a name on it is that ongoing software development is the practice of symmathesy. And that makes me a symmathesist in the medium of software. And the only thing wrong with this slide, well, other than that the word is hard to pronounce, sorry about that, is that my name is on it. Because ideas don't belong to one person. It takes a camerata and then a culture to make them into reality. And I am thrilled to be alive today and in software and in this group where we are exchanging ideas and making resilience engineering a bigger, more real thing.
If we manage to get this right, they'll surrender by early night.
The world will never be the same.
Alexander.
That is my daughter Evelyn singing Hamilton, the modern opera. May our work have such an impact 400 years from now.